I engage with you. I'll correct you where like there's issues. So um I I hope you can like draw properly using your using your PC, because if you're using your phone, it would be way easier. But even if you're using your PC, I just hope that you can be able to write what you want to write. So yeah, let's go into this question. They say refer to the circuits below and answer the questions. Just define the term EMF, electromagnetic. EMF is basically the potential difference. So can you define EMF? Sorry, Kota, do you know the definition of EMF?
I'm not 100% sure.
Yeah, because one thing I can tell you is that I'm sorry, I'm terrible at asking questions. So sometimes you might hear like maybe I'm not asking you a question, but I am actually asking you a question. So can please try to define EMF for me. All you have to do is try, and then if you get it wrong, I'll correct you. If you get it right, then it's fine.
Is it equal to the potential difference of the current flow
You're so near. You're so near.
of no current flow?
Exactly. Like that's our EMF. The potential difference, one, there's no current flowing. So I don't know. I wish you could see me. Thumbs up, thumbs up. So anyway, they say calculate the total resistance of circuit A. So we're gonna look at circuit A now. Can you just like calculate the total resistance? You can either use this side or use this side, or if you want, you can just zoom into it. If you are able to write on the screen.
Do I do the total resistance?
Yeah, just like, how would you write it if I wasn't here and this was a question paper?
Okay.
Yeah, like that type of situation.
Can you see what I'm doing?
Hmm. But there's also like you're on the right step, no? I think it's just the
Yeah.
mathematics part that got you off. So if you look at here, no? You said RT is equal to 1 over 3. So basically here you should have also included your 1 over
Um,
RT. here also your 1 over RT, you know, because it's in parallel. But also the other thing is
Flip.
when you're adding fractions and when you're subtracting fractions and they have the same denominator. So do you remember that?
Yeah.
When fractions have the same denominator, then you only add what's on top and you leave the denominator as it is. Né?
Oh, yeah.
And you'll end up
Sorry.
with 1.5, which is
2.
exactly. And then since this is 1 over RT, 1 over RT, all you have to do now is you take this to this side. Oh, sorry, I wrote R2, RT. Take this up, take this down, take this up, and take this down. And you're gonna end up with your RT being equal to 1.5 divided by 2. Divided by 2. And obviously the common number is gonna be 0.5. It's gonna give you 3 over 4. What's this thing now? Let me do that. It's gonna give you 3 over 4, which is 0.75. So what I suggest now is that if you're not sure about the math, or if you find fractions difficult, because like it doesn't matter anymore. Like you're always gonna use a calculator anyway. So there's no like there is a need for you to learn how to add fractions, but it's not that necessary because at this stage you're gonna use fractions a lot. You're gonna use like your calculator. So if you can't add them like this, use your calculator, you get the answer, and then you end up getting the correct answer. And obviously you're gonna have to use the unit, which is ohms. And yeah, that's the total resistance in A. So we're gonna leave it here as 1 as 11.2. Here, let me put another one here. And we're gonna say 0.5, 0.75 ohms. Goes like that. This one also goes like that. So yeah, but like you were on the right step. It's just the mathematics. Like if okay, the question is out of 2, I can say you would have gotten a mark if you wrote the correct equation. But anyway, let's say 11.3, consider circuit B. They want you to write down the reading on A2. So can you try to get the reading on A2? And if you can, try to explain why you're saying that's the reading. Did you ever?
Yeah, I'm just thinking quick.
Okay, that's good.
Is it still 1.5, eh?
Exactly. Exactly. Simple. Do you think you can give a reason?
Because it's in series and the current flows in the same way.
Equal. The current flows equally.
Okay.
Yeah. So that's that's correct. Like, sorry. That's very correct actually. So now, can you try to calculate the reading on V2 on V1, sorry, for circuit B? Because you remember that day when we were talking about like bananas and stuff, where we're supposed to use ratios.
Yeah. Yes.
So there's actually like two ways to do this. I'll let you choose yours. You can either use your ratios or you can use Ohm's law. So which one are you gonna use?
I think Ohm's law.
Okay. Then that's like way simpler. Try it. Can you please just try to do it?
Yes,
Uh,
I'm just quickly
um,
thinking about what I'm going to do.
yeah, on this side.
Mm,
Nah, I'm just writing Ohm's law for you. Because like they are gonna provide it in the word in your formula sheet. So I think it's just fair that I provided for you too. Yeah, you can start if you're ready.
Hi, sorry, my mom quickly called me.
Okay, okay. Um, then just say something when you're back.
No, that's why the meeting ended. So,
I didn't notice that the meeting that you were out, but can you hear me?
yes.
Okay, I was just saying that I didn't notice because like you have to check here about the number of participants and stuff. But anyway, um, you can start as so long as you're ready.
Sorry, I'm a bit confused. Is it 9V equals 1 comma
Mm,
5 times? uh,
this should be your answer. So basically, what's gonna happen is that we should all when coming to circuits, you will get confused, but don't worry too much. The thing is, we're gonna focus only at a specific point. So what I suggest that you do, no, is that you know that here is 1.5, no? What you can do is that we're gonna just take this. This is it. We're just gonna focus on this part. We're gonna focus on this ammeter, on this resistor, and on this voltmeter. The rest of the circuit, it doesn't matter to us now. You see. So we're supposed to calculate the voltage, which is V1. You can write V1 here, is equal to R, which is the 2 ohm resistor, and I, which is A1. So do you understand now?
Yes.
So can you try it?
Okay. Is that right?
Exactly. Exactly. So that's why the thing is, the reason why in science we have units is so that we can differentiate everything, you know. So we don't just have like 1.5 times 2 giving us 6, because we have to be able to differentiate to say that this unit is for resistance, this unit is for ammeter, and is for current and all these things. So basically, this is correct, but honestly, you need a bit more practice. I'm obviously gonna be honest with you, because in an exam situation, a 2 mark question, it's a 2 minute, it's a 2 minute question. Every mark is a minute. So you have to like you have to get used to calculating these things so that you can be able to get your answers as quickly as possible. But your answer is correct. They say if a third resistor replaces the existing resistor in circuit A, is placed in the parallel, and then now we're just gonna add our let me just add it in the middle. Uh, let me add the resistor in the middle somewhere right here. No. That's not fine. Somewhere right here. And we're gonna have this here. And the and the this. And they say that this resistor is also the same as these ones. It's a 1.5 ohm resistor. And they say, would the total current of the current of the in the circuit increase, decrease, or remain the same? So basically, if you add another resistor in parallel, you're reducing the resistance of the circuit. And once you reduce that resistance, you remember that resistance is, if you rearrange this equation, you're going to end up with something along the lines of, in terms of resistance, you're going to end up with R is equal to V over I, which is actually the original Ohm's law. So if you end up with something like this, you know that if current increases, resistance is decreasing. So if current increases, resistance is decreasing, and if resistance increases, current is decreasing. So what that means is that when we add another resistor in parallel, we're decreasing the resistance and increasing the current. So our answer is gonna be increase. And then the reason is the same as I gave you. When we add a resistor in parallel, we're gonna decrease the resistance and increase the current. So basically what I can say is that if you have time, please do practice these. They take time for you to understand. I actually didn't even understand these things myself in grade 10. So if you want good marks in physics and all these things, you need to like start understanding them early, and you'll get good marks from an early stage. I only started to understand these things around like grade 12. So I got good marks in grade 12, but I got terrible marks in my lower grades. So please, if you have time, please do practice these things. It's very important. And oh, I forgot to ask you this. Do you have plans for varsity?
University.
Yeah, for university.
Yes.
So which path do you want to follow?
The medical field.
Medical field. Oh, then basically it's like it's not necessarily a must for you to know these, but you have to know these.
Yeah. No.
Yeah, but if you're gonna follow the medical field, you have to be very good in life science and chemistry. Life science and chemistry. But anyway, I just hope I helped you, and and I'll see you on Saturday, or whenever you have a question for me. So please do send me those question papers so I can look through them and find the appropriate questions for you for this
Okay.
term. Okay.
Okay.
Uh, Thank you. Have a good day. Nah?
Thank you. You too.
Bye.
Bye.